Welcome, I'm Bill Wake. We're here working on a programming language interpreter for a fourth-like language, and we're to the point of creating the read-eval-print loop, and part of that is figuring out how to get multiple words per line in. We had that facility before, but we've kind of reorganized the read-eval-print loop a bit, and I think starting over on that makes more sense. All right, so we had the loop. Well, we kind of had sort of two loops going on. There's the read-eval-print loop, the big outside one, and then we had a loop in the code that would get us the line of text before evaluating it. We didn't really distinguish read and eval that much, so that inner loop is on eval now. Let's find that. Okay, here's the REPL, and you can see this loop. Back to here, so prompt read eval print loop. Okay, and then eval, we broke out eval 1, but eval had the contents of the dealing with the body of the stuff in there. So I don't see, well, somewhere we called tokenize. We may have moved that around already. But you can see it's tracking that length of the string and moving forward and adding an extra byte at the end and stuff. So there's pieces that we're going to borrow to do the input. Okay, now the input, we still have tokenized loop that does the actual splitting, and we have the input buffer. I'm not sure I want to keep tokenized. We'll see. But here's the core one, is readWord. And so it's got the Unix read that actually reads the input buffer, and then it tokenizes them, and then it sets X10 up to start at the first one. All right, so let's see. I'm puzzled by X10 there. I guess the commented out one maybe made some different assumptions. Move x0, 0, compare x0 to pound 0. Well, that seems okay. I think, I'm not sure what's going on there. I mean, compare x0 to 0 when you just set it to 0. doesn't seem quite in the spirit of what we're after here. But it might have been done on the way to force the original setup. See, yeah, I think this is kind of what we really wanted. Well, maybe this is where I was going to start. So this says load the contents of whatever X10 points to, and then I think if it were instead of this move, we'd compare that to 0. And if it's 0, then we have an empty string, which is our trigger for saying we're out of stuff. Okay, so I think my intent was we would use that, and we know in the starting case we've filled these with 0, so we know it starts that way, and load address calls sets X10. Now, I don't know. I'm kind of in the. I feel like X10 is not really the right one to be using for things. We had a little dictionary, let's see, little design note. Okay, so X10, I really think X22 maybe would be the right one to use, because the high range of registers is reserved for them. Let's go see. I'm gonna, somewhere down here we have our guide. I should pull this to a separate page or something, but X19 through X28 are reserved, and they're intended to be reserved for the caller. So the callee can use them if they, if they can use them for a different purpose if they save and restore them. But X10 is kind of in that temp range. It's supposed to be a temp. Let's not do that. So I guess our first step is going to be a refactoring move to x22 for the word pointer rather than x10. And actually, this is probably supposed to be w22. So x22 is a full 64-bit one. W22 is a word-sized one, but it's able to do byte arithmetic. So I think that's probably more where we're going. Is that right? No, I think that's not right. All right, let's make it X. All right, so I'm just gonna, I don't have a good mechanism. Let's look for X22, make sure nobody's using that. Okay, good. Now let's look for X10, and I'm gonna change all these X10s to X22s. Now, is that, I think I can do that globally. And then, okay, I don't think it'll hurt. We'll just come back and change this. So let's see, is that Control F? Replace text contain matching X10 with X22. Now, why don't I have the replace here? Oh, how weird. No. I don't think that's going to work locally, so that's no good. It's this one that's the right one. But I can't get it to let me do that. Did that do it? Yes. Okay. That should probably be lowercase. Okay, so let's find text matching word X10. No. Okay. X10 with X22, replace all. Okay. I guess it would have been wise to run all my tests first. It looked like it was doing, it looks like it's done every file, so that's good. But yeah, let's make sure it's, well, make sure, are there any that use it twice? Oh, this one does. Yeah, they did replace both, I think. Yeah. Okay. Yeah, good check though. Not always obvious. All right, how are things going here? All right, everything's looking okay. Okay, and then in our design note, I'm going to change that. X22. Okay, so okay. Right. Well, that's a minor thing, but okay. But the real thing is this load address, you have to call input init, but once you do, then we should be able to look at load the byte x0 with the contents of x22 and compare. Let's see how that does. I'm not sure you can detect it with this. Yeah. Oh, right. This is LDR. Is there a compare byte? Okay, so we got load byte W. Oh, right. Yeah, there's that X load. Make sure we get it right. LDRB, but W1. Okay, so we're going to load the byte it points to, compare it to 0. If it's 0, it's sitting on an empty string. And then we're going to skip read. If it's not equal, skip the read. Well, does that look right? Load R. Yeah, I got to get used to that W register stuff. Okay, I think they could give me a better warning maybe. But okay. Let's see. So I know we don't want to skip the read. Oh, yeah, that's why we compared 0 before. Okay, I'm getting there. Yeah, so we did this, well, the equivalent to this. Move that 0 byte in, then compare it, and then we do the read. Well, we're doing one read per, well, one word per line right now. And so we want to move to multiple words per line. Okay. Now, I think the other thing is, you know, the code for this is going to be a little complicated because it's going to manage the end of line and deal with reloading the next input buffer, and then it's going to it also needs to split off those spaces and deal with that. It really should handle multiple spaces, which we don't at this point. Tokenize doesn't know how. And at some point, we're going to deal with strings, which are quote marked, and they should look for a trailing quote, not a trailing space or new line or end of line. So I think that's all going to kind of come into this. And there's logic in that. You know, that's not trivial. Right now, most of the logic is in tokenized, but I'm not sure that really is the right place. Okay, so where I'm going with this is I think we need to test this independently of the actual read. And that's a little work. What's the good way to do this? Well, it's going to be a little work to substitute something in. This is a macro, I think. Right, even though I didn't capitalize it. Unix read. Okay. So I don't know. I think we I think we're going to need to make a function that maybe it just calls this. No, it's going to have to be more complicated than that. When you read data, it should reset x22. Yeah. So I think well, independently of the testability side of this, but I think what should happen is you come in with this pointer. If it points to an empty string, then that says we exhausted our buffer. We need to do a read. If it doesn't, well, either way, well, no. At that point, we've done a new read. We need to look again to see if it's an empty string. And if it's empty, we got to do another read. Okay, because if somebody hits a blank line for, just hits return, that really should not be illegal. I mean, blank lines can help you make sense of things. So I think we're going to have to do some sort of thing where we kind of keep reading until we find something with a non-blank, non-new line character, and then we can pull that. Okay, so we got to do some reads until we get to something with some contents. Once we see some contents, we need to skip spaces and skip leading spaces, put a space at a zero at the end, so it's a string just for that one word. I'm okay to mutilate the buffer, and then move the pointer to say next time you come in after that string length. That's kind of some stuff. So it's going to be some work to get all that together. I think. So my consequence is, I guess, as I think about doing that, I'm going to have multiple scenarios. I'm going to have a situation where you've got a full buffer, an empty buffer, full buffer, that kind of stuff. I think we need to pull that Unix read out. And so I don't know what #0 is. Oh, is the input stream. Okay. A read always defaults to that. Well, no, it's a file descriptor. We get in Unix, you get the 0, x0, x1, file descriptors 0, 1, and 2 correspond to standard in, standard out, standard error. Okay, so I guess it is plausible you'd want to change that on your read. If we're reading files, we're going to take a slightly different approach. Okay. I don't know if it needs to be a separate thing or just a pullout. Well, okay. This was rather than x10. I'm going to at least start our notes. 11th. Wow. And then I'm going to extract a function for Unix read. Okay. Now it can be customized to our stuff, so I don't have a problem there. Okay, so I kind of want to replace this with a call, but I feel like you need input buffer. Are these three things, they just go 0, 1, 2? Yeah. That's almost what you just need to do regardless. Load address x1 to the buffer. Okay. So the result of this is, oh, that's storing a 0 at the end of the buffer. Interesting. Okay, I guess necessary, but didn't know we were doing that there. And then, do we need that buffer after? Okay. All right, let's skip down. This is going to be our reader. Well, no, it's going to have to be a public. Read line. Okay. I'll make it global for now, because we have to substitute it, right? Yeah, I think move to next. Well, the way the tokenizer does it, actually, I'm not sure we even need the tokenizer doing it. Let's see. Let me get this before I forget it. Global. Okay, so tokenize. He does put that byte at the end, but notice that's what our oh no, it's not what our Unix thing did. Okay, this makes it a 0 terminated string, but it doesn't add the extra byte. Okay, so you're right, that is tokenize. Hey, Chandu16. So yeah, this is ARM64 assembler. So we're working on a programming language implementation in assembler, and right now we're trying to build the read eval print loop, and we're working on doing a read and seeing if we can make that function separate so I can replace it when I test. Because the sort of processing, the tokenizing to get one word, it needs to have something in a buffer to look at, but that's not really its problem. You know, we need to test the tokenization, not just the whole thing. Okay, if it were just read this and it's there, I could let it go, but I think pulling it out is going to be an advantage. So what I'm going to say is you need to put well, I guess the calling sequence for readline is going to be move x0 get 0 x load address x1 gets L input buffer, and then move x2 gets input buffer size. Okay, and then we're going to call L. Okay, for now I'm going to say branch to read line instead of the Unix read. And I want to pull this down, but even that is not quite what we need. All right, let's see who uses Unix read now, because I think this may be the only usage. Okay, so input test demo, all right. and then input. Okay, so if we modify input Unix read, I think that's okay. This was us playing around with it, so I'm going to make the same change here. I'm going to let Unix, I'm not going to do this. Unix read is going to take those things. Well, we won't modify it just yet. Okay, this is pound 99 x0 x1. Okay, and then down here. Okay. I guess I could. Okay, let's make sure things are hanging together. Yeah, the tokenizer insert zeros. I don't think it's terrible to do that, but it's got a it does. Well, let's see, tokenizer's in here. It does have to be. Let's see, somewhere there's a string length, right, or something. Go to next tokenize loop. Oh, when you get a new line, we push it in. I don't know. I mean, I definitely have wanted it at least one point here, but I'm not bothered. I mean, the input module owns that space for the read line, the input buffer, and so if it says, I'm fine modifying spaces to 0, I don't think that's unreasonable for it. So it gets in a word, it finds the next space, zaps that. We know the space is not significant because it's a separator, and the first one is really just in the way. So replacing it is fine. I don't think that's an issue. In a more sophisticated setup, it might be, but I think for us it won't be. But I do think what I'm anticipating is we're going to skip spaces, find the next space. So skip spaces moves our pointer forward. Find the next space tells us the end of the string, the end of the word, and we're going to zap that. And that gives us one word returned based on the pointer, but we got to move the pointer past that word to the one after that, and making sure that's okay. I feel like, I mean, it sounds like a nice simple match a bunch of spaces and then find a non-space, just sort of kind of a regular expression sort of search, right? It's just matching characters in this set and skipping over them, and then matching characters not in this set and keeping them. And then the first time it hits one in the set again, it slaps a 0 byte there, and that word is okay. Then we got to come back through the next time and move forward past that 0 byte and repeat the process. But I want to make this Unix read replaceable first. So let's save. I'll do a make. Yeah. Oh, I never fixed that over here. Yeah. I think we'll have to run the REPL just to kind of be confident, because this really is more of an untested area other than manually at this point. Okay, so well, one dupe sub, and we'll do add for different. Okay. One dupe ahead. Well, oh, right. We got one word per line still. Dupe. Add should leave it 2. Uh-oh. Oh, did I do a lowercase? Dupe. And yeah. Okay. We got to deal with that too at some point. Or decide. Okay. So it is reading the contents of the line. All right. Which it should be. All I did was add a bunch of extra loads on the front that get thrown away. So, all right. Now I want to do read line and Unix read can go away, but Unix read where is that thing? I'm changing the interface, so I'm going to say x0 is the file descriptor, x1 is the pointer or address of buffer memory, x2 is the count equals max characters to read. Okay, and then well, okay, so I don't need to do this. I don't need to do this because somebody had to do it to call me. I don't need to do this. But, okay. So I think I can delete these 3 lines. All right, now load address x1 buffer. I think we don't need that. X1 is the address of the buffer memory. I don't think the service call, it's an interrupt, so it should be operating on its own set of registers to change them. We'll find out. Okay. Address. Whoa, wait a minute. Move store WZR x0 plus x1 plus x0. What is going on there? Oh, x0 is changed. But I think we're going to have to say x1 is not. I'm going to say, okay, these 3 go away. We'll have to see. When you call SVC, it definitely alters x0 because that's the return value. All right. Well, let's give this a run. We'll do the same. Whoops. Make REPL 1. Boom. Okay, so it is not the same. All right. So, well, okay, so we're going to have to do some pushing and popping. Okay, so store, let's store x1. And then we got to restore it. But it's here, so it's a little weird. I mean, we're used to doing this at the prologue. X0 is the number of characters read. Yeah, number of characters returned in the buffer. Because we'll say read up to 250 characters. If it comes back with 72, it's going to return 72 in X0. Okay, so this. So here I'm using the stack to keep X1 around so I can use it at the end. x0 is the return value, but x1 is the address of buffer memory. This service routine apparently does destroy registers x0 through x whatever. I mean, whatever the calling standard is, x8, I think. So we're doing the load and store ourselves. This is sort of... It's sort of like putting memory on the stack, really. I mean, that's kind of what it is. All right, so I can make claims, but does it work? One, no. Okay, what's going on? All right, I think we'll step on this. LLDB minus O ripple.out. Break B at, I guess, readWord. Okay, so I'll run. Step, 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 step. Okay, now here's loading x0, load x1, load x2. Okay, reg read x0, reg read x1, reg read x2. Missing a register and setting up the REPL. Yeah. Actually, we're not. Yeah. Oh. We're not screwing around with X10 yet. Okay. FA. What is that one? What's that third argument? Oh, it's the count. Okay. Almost 256. FF would be 255. Okay, so I think we've got our parameters set up. We're at the branch to read line. All right, so I'm going to step again. Now we're in read line. Let's make sure x1 system dictionary plus 2424. All right, we're going to store that on the stack. All right, we're going to move x16 is our request call, 3 is read, x service call, we type in our text, 1. Okay, now still system dictionary plus 24, reg read x0, 2, 1, new line. Okay. Now we're at store byte x0 plus 2. I mean, mem read minus c 50 this. We should see a 1 and a new line in there. Yeah, a 48 is 0. So 49 is 1. 3 times 16 plus 1 is 49. And A is 10, which 10 is new line. Okay, so the memory looks right to me. The length looks right. I guess I'm not sure what the problem is. Okay, so let me look back at the code. Well, we're in Unix read at this point. Okay, we've just done this. We'll do the store byte. Is that where we are? Store x30. Oh, wait. Store byte. Okay. Which will have no effect because our memory already had a 0 there. Okay. But that gets us, oh, well, gee, read line doesn't have a return. Okay. That would do it. Okay. Yeah. All right. Okay. Yeah. All right. Well, I guess I feel better stepping through and making sure everything worked, but okay. So now we have a function that if you set up all the parameters coming in, we can call it. Okay. But the thing I want to do is I want to make that substitutable. Now, I don't know if I should get the x22 thing working first. I guess that's independent, right? The question is, how do we make this call its thing? Well, right now, readWord takes no parameters. So I guess what I'm thinking is readWord should take a parameter. It's the address of the function to call. And then we'll call that. So let's modify that. X0 inputs. X0 is address of the routine to call to read a line. Assumes, yeah, I guess that's fine. Okay. So let's modify the callers of this. Well, yeah, I don't see a way around it. Okay, readWord REPL.s branches to readWord, and then we define it. Okay, so REPL.s. All right. The only thing I can think of, like it would be really handy if X4 was the address to call. I don't know if that's too obnoxious to do. It's a little bit outside the, I mean, you're allowed to pass parameters in these first 4 words, but it's normal that they are in order. So I'm being a little funny maybe, but I think I'll do it regardless. Okay, so REPL is going to load the address of that function to call. Okay, so input should now be able to say BLR X4. Okay, and we made the symbol global so it can get it. Okay, I think we're there. And again, I'm going to do the manual test. 1 dupe add. All right. The reason for the manual test is that's what I'm trying to get rid of. Okay. But I think that's good. Okay, so let's do our regular make. Everything's green. All right. Call read line indirectly so tests can substitute. Okay. Now I think I think in effect we're okay at this point. We've made our substitution. We could ignore that for a while, but I think we're gonna let's fix this initialization thing. We have input init. Is it public? Not yet. Oh, I keep being inconsistent about this. I'm okay for test names. I think for regular names and label names, but I think regular names I'm going to try and be camel cased. Okay, so right now I don't believe anybody's calling this, and our REPL should. REPL. Okay, so part of his initialization of the REPL is really calling input init. Okay, so we need to set that register up before we come in. All right, it won't matter today. Again, I'll make, well, okay, there you go. Apparently it will matter. Assertion failed. Function allocate buffer allocate. See, that's not us. What? Have I input init? Input init. REPL. Input init. That seems okay. We don't have to reference them. Yeah. Make. Oh, thank you. But it shouldn't. Should it affect this? I guess it should. You're right. How many times can I make that mistake in one day, huh? The assertion is beyond me, though. That's something completely different. Oops. But you're right. I guess weird symptoms. Look for that. Okay. So, all right. So now we're calling input init. Beforehand, which is fine. We're initializing another module. Makes sense. Okay. So I want to shift. Let's see. What are we doing? Extract a function for read. We did. I guess I want to shift. Make readWord use x10, not start at inputBuffer always. Okay. That's not really a great description. I mean, no users couldn't read that and know what we're doing there, but hopefully we will. All right. So the deal with that is right now, oh, I guess that's x10. All right, so to me, this X22 represents where should I look for the next word. And I think we can, if we assume it starts, well, what should happen? Okay, if we come into here, I'm going to ignore tokenize. I'm going to say if we come in here and we're pointing at an empty string, that means we've run out of stuff. Okay, because we're assuming our whatever tokenizing we're doing is going to not leave us with empty words until we get to the end of the buffer. Okay, so at this point, well, okay, we come in. If we're at empty, it's definitely time to read. Okay, so I think this is probably right for our purposes. If you come in and the first character is a 0, then you should skip reading. First character is not a 0, then skip reading. If it is a 0, you need to load the thing, call the read routine. Tokenize, and then point to the start of the buffer. Should have a word there ready to go, and we'll return that pointer to that word. Okay, I think this should be the same. It should behave the same, I should say. All right, make rebel 1, boom. Okay, so apparently not. Why not? Yeah, I'm going to type X10 for a while. All right, but now, okay, so we've called input init. So X22 is pointing to the start of the buffer. It is starting out empty because we filled it. So I don't know if we're blowing out here somewhere. I'm going to run this again. So it did the read. Huh. Is it the second read that's the problem? Let's run that again. 1. Huh. Okay, I don't know where it's dying. So 1, and then we got that, and then we got that, and then we blew up. Okay. Step. Okay. I'm going to continue. We'll enter our 1. Okay, and we're back to readWord. All right, now let's read X22. Seems, oh. Yeah, we don't clear, yeah, you're right, it only works once now because we haven't cleared out. because, okay, I think I know. I think the thing is here, we need x22 really needs to skip over that first word, right? Because we're coming back in with x22 pointing at the input buffer again, and it's not changed. It's the same input buffer. Before we always ended up doing the read. Now we're only doing the read. We're not moving forward, so we never hit that second condition. Okay, so well, I'm not quite sure how to best do that. But maybe just write that loop. But maybe this is already why I should be. Maybe I should be working out our tests that use readline. But let's restore ourselves to something, and then we'll start from that testing side. So x22, we've tokenized. I think I got to do this. I've got to go load byte. Whoops. W0 is contents of x22. Go x22 is pointing. Well, it's pointing to the input buffer. That's not where we want things in the long run, but let's keep going. It's pointing to the input buffer. So we want to skip forward, compare W0 pound 0, branch not equal. If it's not 0, we want to move our word pointer. Maybe I should spell it out. I got the mic in the way. I can't see what I'm doing. Word pointer. Didn't think I needed to look at the keyboard, but apparently they don't. They do have little dots on the J, but I just don't seem to sense them. F and J. All right. So x22 pound 1. No. Post increment. Okay. And we're going to do that. So we're going to skip forward until we hit a 0. Okay, so that loop is skipping while the current character is non-zero. We're going to keep looping. All right, and then at the end, the current character is 0. We're going to do an add. x22 gets 1. Okay, so that'll move us to the next word after the next character after the word ended. And then skip read. Okay. Nope. x22 gets x22 plus 1. Okay, that's all good. And make REPL 1. Oh. Is there a word in there somewhere? It is. Yeah, maybe I should just call string length. I don't know. The thing is, string length destroys x0, so I got to go back and get that input buffer somewhere. But you're right. Okay, let's do string length instead. Okay, so x0 gets x22. That's fine. string length. X0 gets the pointer to the word, call string length. X0 is now the length of the string. I don't know, I just kind of want to get through it. X22 gets input buffer. Add X0 gets X0 plus X22. Well, maybe that's more sensible the other way. X22 plus X0. And now I think it's this. Add X0 gets X0 plus 1. There might be a way to fold those two. I don't know. 1. And then now that is X22 gets X0 and load address X0 gets input buffer. I don't know, by the time we finish adjusting. All right, so X22 contains a pointer to the word, so does X0. Length of X0's string is X0 coming back. We load the input buffer again. We're going to say X0 is going to be the old X0, the length plus the input buffer. If we had one character, it was pointing here. Now we're pointing at the 0 byte, and then add one more to get past it. And then we're going to leave that value in X22. Oh, well, maybe I should be adding to X22. 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 X22 gets X22 plus 1. Yeah, okay. Get the input buffer, add X0 to it, add 1 to that. And then load the address of the input buffer so the result of readWord points to a word. X0 pointer to next word. 0 terminated string. X22 is updated. Okay. Reload X0 with a buffer. Yeah. Oops. Okay. Now, I think, I don't know if this is, okay. All right. Okay. Well, I think I accomplished something. Make readWord use X22, not start. Okay, that's true. But we haven't quite done that. All right, I think it's time to make this thing testable, or we've got something we can do, but we need to do it with this. And I'm almost ready to throw away. Not sure we need X0 to be the input buffer. Are you talking about here? String length requires X0 to point to the string it wants the length of, which will be input buffer at this point. I don't think it's right. I mean, that's the thing I want to work on next is kind of, I want to cut out tokenize kind of. I think we'll see. 85 X0 is the input buffer. Yeah, because the result of readWord is the next string to look at. So we mutilated it in the process of getting the length, And so I'm restoring it to point to the input buffer. We're still assuming the first word is always at the front of the buffer. I want to remove that restriction. All right. So let's see. If I give it input, well, let's build up this input tests. Okay, so tokenize. All right, let's go after tokenize. Oh, that's everything. All right, test start. All right, this test can be well, I want to say it's read from read with word in at start. Okay. And then I'm going to need string length yet before the day is done. We have string length. No, what do I need? String copy. Okay. And test end. All right. So what I want this test to be, I'm going to set up an input buffer. But I can't. Yeah, I'm loading up that buffer. Okay. That's where it should put it. Oh, we're gonna write it. We're gonna write string copy. I'm sure this test is gonna need it at some point. What I want to do is define my read function, my read line. Well, I guess this is a stub. Let's say, since we're reading from it. And then I want to call readWord verify first word found. So that's pretty much that's the state that kind of gets us to where we are right now. Now, the tokenize was the thing that put the stuff at the end. Okay. Yeah, I kind of want to get rid of tokenize, but all right. All right. So the stub read line, well, what I'm imagining let's do string copy first. Because the problem is the stub is going to want to create its own little buffer of text, and then we need to copy that into inputBuffer to do anything. And read new line should basically, when it's told, copy the next line of text into the buffer. And that really, a string copy would help with that. It may take a little more. Maybe it's a string end copy. Yeah, let's do that. string in copy. I guess that is like this. Copies empty string. That's always an easy one. Now I don't remember. String in copy, does it copy? I don't know. Maybe I wanted just like a character copy. I don't know. And string in copy copies at most n characters or until it hits an end of a string, I think. Yeah, you don't get a null byte at the end. Mem move. Yeah, I kind of want that. Okay, I'm gonna make a function I'm gonna call string copy 2. And it's going to copy a string, and it's going to stick an extra 0 byte after it. It's a little obscure, but I think it will help us quite a bit for what we're doing. All right, so we need to point to an empty string. I guess x0 is going to point to let's put some data in here. Line 2, text, line 2. ASCII Z empty string. Okay. And then I want to make a lstr copy target. And I'll say fill, let's say 20 bytes, 8 with FF. Yeah, str copy NL. NL? I mean, we're not putting a new line in. Str copy. Okay, well, we'll keep the name on hold, but I'm going to keep it in this file for now. I could say str copy 00. str copy Z, I like that. Okay. So load address str copy Z empty, and then all right, let's see, that should be x0, and then x1's where we copy 2, target, and then we're going to call struct copy Z. Okay, and that is here. Okay. Yeah. Perfect. All right. So the assertion then, I guess we're going to look at I think I'll just load the target and compare bytes. X0 string copy target. I'm going to load byte. W0 gets X0. And then move X1 gets #0 assert equal. Okay, so if you, all right, we load the source and the target, and then we're going to look at the target and make sure the first byte is a 0. All right, and then I'm going to check the second byte. Now, I thought there's a mode. Isn't there a mode that lets us add directly? It only works on some things. Modes. Yeah, this one. I think we can do that. #1. So now we're going one further. X1 should still be 0. Okay. Yeah, this, I'm filling this with junk, so it should be okay. Okay, and then this test, put that up here. Fail. It got a 255, which is a, FF, and I expected that. All right. Now the second one passed. That seems odd. All right. X0 is the target. X0 plus 1. How is that not an FF as well? Okay. Okay, now we're in our routine. This stuff. Okay, here we call string copy Z. And address of X0 gets 1. 2D. Okay, that's the load address. Reg read X0. 402D. Am I off somewhere? No. No, it does not. So no, I'm wanting to copy the empty string and then put an empty byte after it is what I'm hoping for. And we just return off string copy Z, so I don't see the problem. All right, let me see this dump. I'll be right back. Okay, sorry. Yeah, I don't know what happened to our dump. Let me make a new. Well, none of these sound okay. I don't know what happened to my commands. I somehow got rid of obj dump. Wow, there's more than I remembered here. Options. I don't know, do I have that in here? Okay. What was it? Input test out. Okay. And then my font is a little small, but all right, I'm trying to find 402D. Oh, which is an address. So there was another parameter. Man, obj dump. Was it real? Minus S? Yes, there's 40E. .402. Okay, 402D 0, 1, 2, 3, 4, 5, 6, 7, 8 A, B, C. Okay. All right, I guess that's 8, 9, 10, A, B, C, D is F, F. String Z copy needs to put a 0 in the first position. Yeah. I'm not sure how it got that far. All right. Yeah, let's. Well, okay, what I want to do is x0 is x1's the target. I just want to move store byte. Can I put a literal here? CC at x1. Okay, so I'm going to put some junk in somewhere in the middle, which shouldn't affect those two, I don't think. All right, let's quit. Okay. Well, this can be WZR. W0, write that byte into address X1. So I should have FFFFFFOC0. Okay. But you're right, if we don't, the fill needs to be of size 1. I thought it was writing 20 bytes of contents this. Let's make sure. Repeat copies of size bytes. Repeat maybe 0 or more. Size is... Oh no, you're right. That's weird. So I should repeat 1, huh? More than 8 is deemed to have 8 compatible with other people's numbers. Repeat bytes is taken from an 8-byte number. The highest order 4 bytes are 0. Yeah, bizarre behavior is right. Okay. Okay. Let's do this. You know, I'm going to do something even more wrong. Okay, so I think I'm writing CC 0 byte. Size 4. Well, 4 is still 4 bytes, right? I think. Plus, we don't know if our assembler is 100% GNU compatible, but usually I don't think you'd defy everybody. All right. All this is to get a good failing test. Store byte WCR. Move X0. Well, how do you... Wait a minute. Move X0 pound... Oh. Okay. 204. I'm one to believe that's CC. Okay. And they both fail. All right. That makes me feel like we got a good failing test anyway. Sometimes it's a little more work than you want. Okay. So then if we did the right thing, well, I should take X. I guess I need to load. Let's load byte. I guess we need some temporary pointers, right? Because we're going to mutilate x0, x1, or the temporaries, doesn't matter. Okay, so I've got to... Oh, I'm allowed to mutilate x2, so there's no problem there. All right, so I'm going to load the contents of that thing there. I'm going to compare it to 0. I feel like I should be able to do this backwards. Yeah, 92 is C. Yes, good, thanks. Okay, I compare. If they're equal, well, I'm going to branch to that end. Okay, more is going to happen down there. If they're not equal, otherwise I need to copy x0 is my starting point. Okay. Maybe I need to repeat until. I guess I'm going to say move. I don't know. So I guess what I'm saying is repeat until the value I just copied was 0. I'm going to move the contents of what x0 points to the contents of what x1 points to. Okay, so move store byte. I guess I got a load byte. x2 gets x0. Okay, that's fine. Store byte. W2 gets x0. Store byte. W. W2. Contents of x1, because that's the target. Okay. And then I'm going to increment them. Post increment. Post increment. Okay. Can I do that? Okay, and then I'm going to branch to keep okay, so move W2 loads up the current x0 and post increments it. We store it in the contents of x1 post incremented, and then we compare the byte we just copied. If it's not equal to 0, then it was a good word to copy. All right, but now we just copied the last byte. And I want to do my extra. Okay, let's leave out that. Okay. Okay, so this is sort of a classic loop in C, right? The string copy was originally something like, while star target equals star, while star target plus plus equals star source plus plus, semicolon, and it's just like copy all the stuff until the byte is 0. Okay, so I believe this will do the first half of our test and fail the end. Oh no, I think this will fail the end. Pass the first and fail the second. All right, I feel like that's progress. Yeah, we haven't added 0 yet, but we know where it goes. It goes x1. So x1 is, we just copied the last number, so store byte 0 at x1. All right, let's make sure. So we copied it. Yeah, I think it's just stored x1. Because let's say we got an empty string, right? So, okay, okay. Yeah, because I think we've moved the pointer past it. We definitely moved the pointer at least once. So if it was the 0 byte at first, we've moved the pointer, so now it's pointing past the 0 byte and on the source and the target. So we need to write that extra 0 byte. Okay, so this is write the extra 0 byte. Extra. Okay. Okay. Input x0 source, x1 is target. Uses W2 as a temp, and then it does not return anything. Okay, so now I feel like we've done the right thing, period. Maybe I jumped my test a little bit. Let's make another one of these. Non-empty. ASCII dupe. All right, so this should be non-empty. And then this time, str copy z. I think we know. Well, I think string copy z and string copy target should be the same. Should be the same as our source. And we call it assert equals string, I think. All right, but this one, as string copy 4, target plus 4, plus 0 is D, 1 is U, 2 is P, 3 is 0, so 4 should be the extra null byte. we didn't add a cert equals string. Okay. Not that it's useless by any stretch. Okay, so BL string EQ, and then the result is x001, and we'll load, we expect 1. Do I need a second 0 at the end of the string copied? No, I need to. We definitely don't. There's 1 0 there, but we're checking 0, 1, 2, 3 is the 0 byte, and then 4 is the byte after the 0 byte. It should also be a 0 byte. Okay, so I think we're okay. No. No, that doesn't seem right. Oh, I gotta load the byte. X0 is the contents of X0. Well, I guess I can put the 4 there. Where is that? Copy Z target. Load that plus 4. Okay. Whoops. Invalid operand. Oh. Oh, it's not empty string. Okay. All right. Now, let's see. Let's at least add, define a string copy Z that copies string plus extra 0 byte. Okay. Well, I think that's a good place for a break. Let's take a break. We'll come back. I think we have to do a small bit of refactoring that we want to make this. I don't know if it's a more general thing or if it should just be part of input. Probably just input for now. It's a little specialized. Okay, so we'll come back, move that to a separate file, and then move on to the tests that actually test our input. All right, see you in a few minutes. Okay, welcome back. I think maybe this function should live in our C-like area. It's really needed by the test more than it is by our code per se. So I don't think it belongs in there. It's complicated enough. Well, I could see other tests needing it maybe, but I think we'll go with that. Wherever C-like is. Okay. So we have string Q. Let's just add it down here. String copy Z. Maybe up there would be better. Okay, and then we have a C-like tests. Nope, I need more than that. Okay, so C-like. Reference from input. Oh, yeah. That is correct. C-like. Okay, string copy Z plus that. Okay, good. Okay, now kind of on to the main event. All right, so we're at start. Yeah, so this is kind of, yeah, I'm kind of verifying what we do right now, I guess. All right, so let's define our read line stub. Stub read line. Okay, and then return. All right, now what does it take to do a read? Let's go back to input. Well, this kind of stuff. Because we want the same interface, but our data is going to be in here. Read source 1 is going to be ASCII. Dupe. Oh, now this is interesting. Is this... Do we want to assume the input buffer here? I think we do. So does that mean we have to pass that too? Or we have to expose it to the test one way or the other? I guess I'm going to expose it. Input buffer. Okay, x0 is the descriptor. So in our test, let's see, it's our real code that does that. We don't have to care. I guess we don't care about this stuff. We got to do a load address x4 gets L read source 1. That's our stub. We'll do a start first. Input init. Then we're going to load this. Okay, that defines the stub. We're going to call readWord. And then we want to verify that. Actually, we don't need this in here then. All right, then I guess it's just asserting, right? So we want to say, yeah, I guess we want to say string length. So let's load address. Oh no, x0 comes back as the length there. So load address x1 with L read source 1. And then BL string AQ, and that gives us x0 move 1, x0 gets x1 gets 1, and assert equal. X1, we're going to go back and look at the string okay, X0 is the string we got, X1 is the string we want, should be equal, check that they're equal, okay. Now I think this will fail because our read line just does nothing, and I don't call it. Oh, there it is, illegal instruction. Okay, I don't know what the instruction is. Yeah, does readWord do that? That's a good question. But it's what I would like to happen, that you call readWord and you get a pointer to a word. I believe it does. Yeah, we point it to the input buffer now. So at least for the moment, that's okay. What is my problem though? Read word at start. Read with word at start. Real load address. Read word. Oh, I didn't do my lines. Nothing else. Illegal instruction. Okay. 3CE0. B 3C E4. Oh, what's this? Read word at start. Stub read line. Download that. Oh, pointed at the wrong thing. Okay. X4 is the word we want to read, the read line method. Okay. I think that's better. Good. Okay. Copying to a writable memory block. Yeah, so I think it was that I didn't, I had the wrong address here. So the readline function was pointing to the read source, which is dupe, which is definitely not an opcode, except by pure dumb luck, if it is, and it wasn't. Okay, so what's happening? Well, okay, our readline doesn't do anything right now. That's the real problem. Let's get the Unix one up. No. I guess we need the input one. Okay, so here's our read line. It actually does the Unix stuff, but we're going to modify this. Well, we need to take this stuff into account. Okay, so our test should do the equivalent. Okay, so we need to move X0 let's see, our read is X0 is the file descriptor. We're going to ignore that. X1 is the input buffer. That's what we need to write to. X1 is, well, X2 is the input buffer. Okay, so we're going to want to call string copy Z in, copy Z. Okay, so X0 needs to point to the input. Input buffer. And the size? Well, I don't think we need to worry about the size either, because we're just going to copy in our stuff. So load address lread source 1 goes into source. So we're going to say move, no, X1 is already X0. Okay. Let's see. Okay, so if X1 is already our input buffer, that's our target. Our source is going to be lread1 source 1, and we're going to branch to string copy Z, which will copy the stuff into the buffer as if it were read once. Okay, so I think that will do it. Read with word with start. Where are you? Input test. Oh, no, it's frozen. Huh. Now, was it frozen waiting for input or frozen waiting for something else? Okay, so we basically copied read source 1 to inputBuffer. Okay, now is there anything else that's supposed to happen there? That seems like about it. We kind of ignored those other things. BLRX4, did we make our REPL use that? Yes. Sorry, let's make sure our test did. Load address X4. Okay, input init. Now readWord. So readWord should do its thing calling read line. And when it gets back, that should have valid data in the input buffer, which is X1, which is the target. Okay. That feels okay. Now ours, it just seemed to freeze right there. Okay, I'm gonna run. All right, we're at the start of our test. Okay, we're in our test proper. X28 string length. Oh. I'm just going to run. No, continue. And we're there. As if we're at the terminal. Well, is there any assumption in here? We're calling read. The input buffer should start there. Okay, let's break in our stub. I guess I'm gonna have to do it that way. Yeah, readWord doesn't loop yet. It skips, but I think we should be starting with X22 pointing at bad stuff because we did call input init here. All right, let's break here. I don't think I need to make it global to break on it. We'll find out. Good. I'm going to skip over this one. Mem read count to 50. Where's input buffer? Can I do this? No. Look, it half knows where it is. Okay. .404C. Well, nothing's there. Tokenized does loop. It almost seems like, well, we did what I thought would do a string copy, right? And it didn't seem to put it there. Or didn't seem to put it where I expected. X0 is our input. So copy Z, we go back there, C like. X0 is the source, X1 is the target. So, well, it's frozen, right? So somehow, well, where are we, right? We're string copy Z. Oh, I haven't executed it yet. Okay, let's, I don't know where I am. Did next, then I did some reads. Okay, I'm at the start of string copy Z, so I should, I'm just gonna step a bunch. 1, 2, 3, 4. And then one more, I think. Right. Okay, now door mem read. Okay. Dupe is there with the 2 following bytes empty. Okay. So that seems good. So our read line is being called an input. And we are returning from that. We should load the input buffer and tokenize. Well, maybe tokenize is not happy. Okay, so why are we going to print? Read with word at start. I don't know why we're there. Oh no, we're on the return. Okay, so let's return. Our return is screwed up. BLR. Oh, it might. But I think this is saying our return screwed up because this was the end of the stub. And we did call it with BLR. I gotta Yeah, we didn't save LR. Did we call anything though? Where's our stub? Oh yeah, he does. Okay. We'll have to do the save restore. So I think our stack got trashed by the string copy Z, and now we have to put it back. And LR is the thing that points to the return address, so that was screwed up, and who knows where we're going at that point. Well, it's a theory anyway. But anytime we call a routine, we're supposed to do this. But yeah, you may be anticipating the next problem. Make. Okay, now that's passing. All right. So write test using stub for read line. Okay. And apparently tokenize was okay. But I think what I want to do, all right, now I want to break things. All right, so when you come in 66, and if x22 points to an empty string, so x22 should be pointing to the string you want to read next, and if it's empty, that means the buffer is exhausted, and we need to do a read. So lines 70 through 72 seem okay to me. Now replaced NL with 0. Oh yeah. So I think it's okay. I'm going to get rid of it anyway. All right. So if you do this read line stuff, okay, then I want to skip spaces. I mean, I'm pointing to something that could be a word. So I'm thinking of our input line where we had one dupe sub on the line, or from your side, one, I don't know which way it is now. I have my screen flipped because when I try and show people dulcimer playing, it's easier for them if my hands are going the right way to them. But I'm not sure where that leads me. Maybe it's good for this too. All right. So, I think what should happen is after you've read the line, we should go looking for another word. All right, but I think what we should do is be skipping spaces. So I'm going to make this next test. I don't know how far we'll get. Not very. But we're going to put a new capability in, which is to skip starting with spaces. Okay, so I'm taking the simpler problem first, but eventually I want to be able to read all the words in one line. So what I'm saying now is you're coming in, you're pointing at a string of some sort. We don't know how it got there, but you're pointing at it, and you're supposed to skip spaces and then read the string and then stop when you hit the next space. All right, so your starting point is, well, I'm going to give it a different, how can I do this best? And let's do sub just for variety. Okay. Now this, I'm going to have to extend it or do something. Put a macro. I don't know, because at some point I'm going to want to say, I'm going to have an array of these things and you ought to read any of them. or else I'm going to start you with an index. I don't know. That's some cheesy thinking here, but okay. Somehow, but we want to do this with source 2, which we have to work out. We're going to branch to readWord, and we get back, well, source 1. Then I want to move forward. X1 equals X1. X1 equals X1 plus 2 spaces. Okay. And I expect to get this string back. Okay, this should fail. And I'm accepting it's going to fail for the wrong reason, really. It's my test is not quite right yet because I don't handle source 2. I may give myself, I don't know, some data somewhere. All right, let's see it fail. Let's read with words starting with spaces. Okay, yeah. Segmentation fault. Not the failure I really expected. Oh, read source 2. Segmentation fault. All right. Just to see where it crashes. LLD name unsimilar. String EQ. X0 and X1. Well, that can't be right. Have I not loaded the address? X0 is the read word. Is there breaking because tokenize is replacing spaces? Well, I would have expected because it saw the first space. What would happen? It's going to replace the first one. I would expect it to turn space sub into 00 sub. It might not have, well, no, it would have the 0 at the end regardless because we put it in here. And where was it dying? In string EQ. Because X0 is not the right thing. Well, that almost sounds like a read word to return something weird. Because remember, in this test right now, we still read stub only knows how to read source 1, which is, oh, dupe. Okay. I don't. So, oh, sorry. What? Okay, that should be okay. I don't see why it's not the same. Now I'm reading P, string EQ 0. Yeah, but it's blowing up. 064. I mean, in string EQ, X0 should be whatever's here. So, I guess I wish I were back a few instructions. String EQ. Well, let's look at X1. 3C5A. C5. Oh. Okay. 5, 4, 5, 8, 8, 9, 0, 0 space. Okay, so 5A is the space. No. Well, yeah, 5A is the space. So 5, 8, 5, 9, 5A is 20, which is 32, which is a space. Yeah, I could write a second stub. I was thinking I'd like to be able to feed in a series of strings. I don't know. We'll see what we're coming up to there, but because I definitely have some tests. Like I want to test that if you do string empty line string or something like that, is 3C5A. Yeah, I don't know. Is that what that's going on there? 62 is 6 times 16? No. 96 plus 2? 98? I don't know. It tells me I should use capitals because I know my ASCII better. But I'm most worried. I mean, that seems plausible to me that this is right because it's the spaces in there. It does tell me I should probably make that global just for our purposes here, but but why this is 64, that's just not right. Okay, so when we come home from readWord, the load address X0 should be inputBuffer. Okay, so I guess I'm going to break on readWord in the next 60 seconds. Break set readWord, break set -b readWord, and run. Yes. Okay. Now, step. All right, what's readWord doing? So compare, branch not equal, okay. But it is equal, so we keep going. BLRX4 is our return, our stub. All right, I did next, so we skipped over that. Now let's see X0. Okay, plus 204. That sounds right to me. That sounds like the place it should be looking. Okay, so so we're here. So if I step over this, X0. Okay, I don't care what comes out of this, but I should be able to say mem read 250. This, and we should see our word there, 3F 3C58 space sub. Okay, so our word did get stuck in. Maybe it is a tokenized thing. Okay, now we're ready to tokenize. What does tokenize return? Put the string has all spaces. We're not really promising any output. We'll just muck with memory. Okay, so if I step next and do our memory again. Still space stub. Okay, I'm with you. I'm not trusting tokenize. All right. Well, we're out of time for today. We'll pick up there tomorrow. I think we'll be continuing to rewrite this. Clearly, tokenize didn't seem to do the right thing with the spaces. That seems funny to me. But I don't want tokenize involved really. So we'll have to see. But I really do have in mind some other thing that goes on where we load that buffer and then we're back in some sort of loop that skips spaces and then skips non-spaces and then places a 0. And that leaves X22 pointing in the middle of the buffer where we want it for next time. So I think we'll make that happen. It'll put a 0 at the start. Well, that's what I thought it should do, but it's still got, oh no, I'm not looking at inputBuffer. Okay. Dupe. Now I'm really puzzled. Okay, we haven't called tokenize yet, I guess. Okay, at any rate. Yeah, so we'll pick up there. We'll work on modifying this thing to not need tokenize. I don't even want it to do anything other than skip spaces and find the end of the word. I feel like that's enough for it because we're maintaining that state of where things are, and we don't have to rely on always starting an inputBuffer, which is what tokenize kind of does now. So I'll see you hopefully tomorrow or some other time. It's 2 to 4:30 p.m. Eastern Daylight Time or 6 to 8:30 p.m. UTC. I'm not sure if England had their time switch or not, but somebody corrected me on the UTC, like, yes, you have to move your UTC time. You changed. All right. And anyway, hopefully one of those times will work for you. Thanks. Take care. Bye-bye.